All right, there's question one on the exam. Question one, and the board needs to be dried. So question one was balancing a chemical equation, and the equation looked as follows. So you may or may not have noticed I copied this directly from the book, so absolutely nothing original here. C7H5, O6N3. And the idea is that atoms are neither created nor destroyed in chemical reactions. You'd have to go to a fusion reaction to have that happen. So what does it mean? We'll have the same number of carbon atoms on the left and the right-hand side, same number of hydrogen, nitrogen, and oxygen. So we're going to need some coefficients here. So let's say x of 1, x of 2, because we don't know how many molecules would be involved, so that the number of atoms is preserved. So plus x of 4. Again, you can call those coefficients anything you want. But at any rate, what would I have? We have 7 carbons here. And we don't have any other carbons there. And that has to equal the number of carbons on this side, which is only found here in this molecule. So 7x of 3. And let's see, in terms of the hydrogens, we have 8 of them here. 8 hydrogens from there, 2 from here. So plus 2, 1 hydrogen. Oops, 1 hydrogen. So x of 2 equals, and then 5 hydrogens here. So 5x of 3 plus 2 hydrogens and good old H2O over there. So, 2x of 4. And nitrogens, we have 1 nitrogen here, so x of 2. And nitrogens on that side, they only appear here, right there. 3 of them, x of 3. And finally, oxygens, 3 of them from that molecule, so 3x of 2 equals, what do we have on that side? 6 of them here, so x of 3. 6 in front, and 1 of them there, x of 4. There's the system. Let's tidy the system up. What do I mean? Let's get everything on the left and zeros on the right. There's no constants hanging out by themselves. So if we do that, we will get from this first one here 7x of 1, no x of 2s, I'll leave a little space, plus 7x of 3, no x of 4s, I'll leave a little space, equals 0, except this should be a minus. From this one here, we get 8x of 1 plus x of 2, bring this over, minus 5x of 3, bring that over, minus 2x of 4 equals 0. From this equation here, x of 2 minus 3x of 3, 0 there equals 0. And finally here we have 3x of 2 minus 6x of 3 minus x of 4 equals 0. There's in a more standardized format. I'm not going to bother to solve this right now, and I didn't say how you had to solve it. You can solve it by elimination, substitution, use your calculator, use a computer, software, whatever you want to do. If someone didn't tell me how to do it, I would probably go to a 4 equations and 4 unknown solver online and just enter the coefficients. 7, 0, negative 7, 0, 0. 8, 1, negative 5, negative 2, 0, so on and so forth. Press solve, and you get your answer. Ta-da, and there you go. Okay? You know what? One thing that could come up is, oh my gosh, maybe I should solve this one, because there is that issue of what if you have free variables, and the issue that we need these all to be whole numbers. Oh, brother. So, yeah, let's go ahead and let's at least get this in echelon form. That's yuck. Oh, my gosh. Why do I say yuck? Well, first off, I got 7, 8. I don't know, not really nice numbers. Tell you what, let's divide the first equation by 7. Let's get that done. We'll get this like this. There, at least we have that leading coefficient there is a 1, and that's nice. Then how about this equation? How about if we subtract 8 of these? Let's take this equation and subtract 8 of these. And if I do that, so I don't have to rewrite everything, I want to remember I'm going to subtract 8 of these. This will be gone. There's nothing there, so that'll stay the same. I'm going to subtract 8 of these, so I'm going to add 8 of these, so this will be plus 3. And I'm going to subtract 8 of these. There's nothing there, so that'll stay the same. Zeros, make it homogeneous just to make it nice to work with that. So that went by pretty quickly. Okay. Let's see. Let's continue on. Look at this one right here. How about if I just straight away subtract this equation? The x sub 2 will be gone. I'm going to straight away subtract, like I said. If I subtract, this will be a negative 6. There's a 0 here I subtract, so I'll have a plus 2x sub 4. That'll stay the same. Let me go ahead and divide this equation right here by negative 6. I'm going to divide by negative 6. Divide by negative 6. Divide by negative 6. Negative 1/3. This equation down here, let's see. Let's subtract this equation. We'll take this equation, subtract that equation. 3 times that equation. So this minus 3 times that equation. That'll be gone. I'm going to subtract 3 times this equation. So negative 6 minus 9. That'll be a negative 15. And I'm going to subtract 3 of these. So that means I'm going to add 6. So negative 1 plus 6 is plus 5. And now I need to get rid of, look, there's our leading variable x sub 1, x sub 2, x sub 3. Let's get rid of this right here. Oh, yeah, I'm glad I'm going through this right here. I'm glad I'm doing that. Let's see this one right here. How about if we add 15 times this? We'll add 15 times this. So if I add, I don't want to forget this, right? I should write it down. Add 15 times this. But if I add 15 times this, that'll be gone. If I add 15 times this, I would be adding negative 5. Oh, hey, that goes away. Look at that. Boom. So what does it mean? It means we have a free variable. And that means x of 4 can be anything that we want. Now, we do want it to be a whole number. However, look, from this equation right here, look at this equation right here. We get x of 3 equals 1/3 x of 4. So one thing I notice is that whatever x of 4 is, I want it to be something so that x of 3 is a whole number, because we need a whole number of molecules. Well, what would be a convenient choice? I say so far, because I don't know where this is going altogether. But so far, maybe I'm thinking, hey, maybe make x4 a 3, because that would make x sub 3 a 1. But come back and look at this equation right here. What do we have? We have x sub 2 is equal to 2x sub 4 minus 3x sub 3. So x sub 2 is equal to 2x sub 4 minus 3, but there's x sub 3. X sub 3 is 1/3 x sub 4. So if I put a 1/3 x sub 4 in there, what do we get? We get minus x sub 4. Double check the arithmetic on that. Yeah, and so x sub 2 is equal to x sub 4. Well, I like that, because if x sub 4 is a whole number, then that'll make x sub 2 a whole number. We got to go back and get x sub 1. Well, it turns out that x sub 1 is equal to x sub 3. So one solution, and there's an infinite number of solutions, right? You could always just put any multiple of the number of molecules. But one solution is to have x sub 4 equal to 3, and that will make x sub 3. What was x sub 3? X sub 3 was x sub 1. And hold on a second. Well, let me just get x sub 2 first. I think we'll get all these here. X sub 2 is x sub 4. So that'll make x sub 2 equal to 3. Down here we have x sub 3, 1/3 x sub 4. So if I make that a 3, that'll make x sub 3 equal to 1. And like I said a second ago, x sub 1 is equal to x sub 3, so x sub 1 is equal to 1. And there is the solution. So it would be one molecule here. If I wrote it out, this would be a 1, and then x sub 2 would be a 3. So this would be 3. And x sub 3 is 1, like that. And x sub 4 is 1. So that would be that. I feel like x sub 4 was a 3. Sorry about the 3. Hey, how can you check this? Well, I don't know. I don't know, but what I mean is you could take, there's 7 carbons. Okay, there's 7 carbons. Here we get 7 carbons. Okay, the carbons check out. What about here? We get 8 hydrogens. We get 5 hydrogens. Oh, come on, for crying out loud. This is not right. man, that's really, really annoying. Oh, no, wait, sorry. 8 hydrogens and 3 more, that's 11. And there's 5 hydrogens and 6 hydrogens, 11. Whew. Okay, and here we have, what else we have? Hydrogens we already took care of. Nitrogens, we have 3 nitrogens and 3 nitrogens. And what about oxygens? We have 9 oxygens there. We have 6 there and 3 there, 9. So that checks. What was the next question? I'm worried that I'm going to lose these videos. If I make them too long, they get lost. Number 2, I think I can dispense with that kind of quickly. Number 2 was a direct copy from the book, except I multiplied the equations by a constant. So let's see here. Hold on a second. So for question number 2, we were given the following. 2u minus 2v equals 2, and 8u minus 8v equals t. And the question is, for what value of t could we possibly or maybe get no solution, infinite number of solutions, or a unique solution? Remember, whenever you have a system, you can do those row operations, and you get an equivalent system. So to make this just easier, plain old easier to look at, let's divide both sides by 2. We get u minus v equals 1. And here we get u minus v equals 1/8 t. And maybe this is one of those questions which is easy enough that it makes it tricky. One thing you can tell is that if t were to equal 8, then you would have u minus v equals 1 and u minus v equals 1. Both equations would be the same. So you could erase one of them, it's redundant, and you have the equation of a line, and each point of the line is a solution for the equation, so you have infinite number of solutions. So if t is equal to 8, we have an infinite number of solutions. So t equals 8, an infinite number of solutions. Now, what if t is anything other than 8? Just think about it for a second. If t is anything other than 8, since u minus v is equal to 1 and u minus v is equal to this, we would have 1 equal to 1 over 8 times t. If t is anything other than 8, this is a contradiction and you have no solutions. So this is a case where you either have an infinite number or no solutions. There's no way to get a unique solution out of it. In particular, we'll talk about coming up here because this really is a linear combination of that, the left-hand side. Nonetheless, t equals 8, we have an infinite number of solutions. T is not equal to 8, we have no solutions. Okay, I'm going to end the video real rapidly and come back and post the rest of the questions.